What if we combined artificial intelligence and space technology to get access to more resources than we've ever had access to before? Currently, scientists spend months analyzing data for even the smallest sign of other minerals from other planets, meteoroids, asteroids, and other bodies in space. We could do it in hours. Meteoroid mining is currently the backbone of mineral supply. That's how we get our phones, our technology, our energy, and way more things. Satellites also use images or take images and send them back to Earth of other planets and asteroids, but planetary geologists spend months analyzing them for signs about minerals that we could gain from these other locations. AI could improve both of these issues. So the samples are taken from outer space and delivered back to labs on Earth to determine their mineral identities and content. But this is time-intensive, very expensive, and outdated. Understanding the geological makeup of the unfamiliar bodies in space is more daunting. It's still doable because of the many sets of data that planetary geologists have already analyzed to identify fissures, plateaus, and seas of hydrocarbons. So how does AI 10x these processes? Using an unsupervised machine learning algorithm which enables planetary geologists to find all kinds of unknown patterns in the provided data, scientists can perform a month's work in hours or less. So for meteoroid mining, metallic ore deposits and their constituent minerals have characteristic properties that are visible by evaluating them with different wavelengths of light that are beyond the visible range. These unique properties can be evaluated to map the distribution of specific minerals. The WorldView 3 satellite images show in the first box, labeled number 1, a natural color composite. In the second box, an iron enhancement composite showing differences in iron mineralogy. In the third box, a clay enhancement composite showing the differences in clay minerals. And in the fourth box, a lithologic composite showing differences in the geological units. So these images would be compared to images in other locations and having similar outcrops, and the AI would try to detect if the two photographs are similar enough that the new location might have the same minerals as the other one, and then if it's likely, an expedition team would be sent out to further explore and evaluate the area. A similar process would occur for understanding the geology of a new planet or asteroid or other body in space, wherein the unsupervised machine learning algorithm will perform an analysis of the geology in an image of space and then try to figure out what minerals might be present there based on that. So in this image, the asterisk shows a wrinkle ridge in the Mare Imbrium, which may not have been previously spotted without AI. Satellites are capable of mining satellites capable of mining asteroids already exist, as well as the AI technology necessary for detecting minerals in different wavelengths of light. All that needs to happen is the merge of ideas so that we can start gaining valuable resources from space to use back here on Earth.